All right, so let's see if you're going live. All right, I think we are live now, so going to go ahead and start. So it's been a while since I streamed, so I was working with Ollama and I ran into a curious little bug where I was using Dolphin Coder and it was repeating itself. So I wanted to dig into Ollama to figure out okay how it works and so on and so forth. So this stream is me, trying to just be curious, try to figure out how Ollama works. I'm going to pull down the source and then see how that works behind the scenes. But let me show you what I have been doing though before that. So here in this particular case, what I was trying to do was I was trying to do engineering for prompts. I hate calling it prompt engineering, where I wanted to do this. So let me start Ollama serve, and let me go ahead and hit this again. So I can do a space st where it tries to get the syntax tree for this, tries to figure out the current token, get the data out of it, and it says, oh, generate a test for this particular method. And I'm using Dolphin Coder. So I used to use GPT-4 and GPT 3.5 both for this, but I've been liking Dolphin Coder a lot. But yeah, I want to get one connection. So this is not that great because I asked it to use SQL test and it's doing this. So let's generate this again, see if we can get a better response. So let's see. So it's okay. So it does a block on. You don't really need to do a block on to do this, but you get the idea. I mean, maybe with a little bit of better prompting and better this thing, maybe it'll do a better job. So let's see. Yeah, I mean, it kind of works, this one particular thing. It's just the thing that is missing, the SQLX, this thing that's missing. Let's see if I can get it to work. Because I think earlier it was giving me this better, let's see, CFG test. And this is something that I want to change as well. I want to move away from OpenAI and to use local models, but let's see how this works. Yeah, this is clearly not going to work. Or let's see, SQLX test. And let me kind of format this a bit. I know I could do a put C on it. I have that configured as well. But all right, so let's see if this works. AF. Yeah, it kind of worked. I mean, of course, I know what I'm doing, but yeah, I would have expected it to generate the whole thing, but it's not too bad. We didn't change the test code as such. But yeah, so I've been finding Dolphin Coder is surprisingly good, given the fact that it's running locally on my machine. But yeah, sometimes Dolphin Coder can go on a loop and then it can keep chatting with itself. But let's look at Ollama and see how that works. So I'm just going to I'm just going to the canvas. Give me a second here. All right. So I'm going to first talk about what Ollama is in this case, right? I think many of my viewers would already know this, but just to be sure what this is. Now, we have these different LLMs, right? So, and the one that I'm using right here is Dolphin Coder, say. But for sake of simplicity, let's call it, say, something like Mistra. All right. So now these are essentially published on Hugging Face or things like that. But then there are quantized versions of this that are released, and this would essentially be like a 4-bit quantization or a 8-bit quantization. So, and there are various formats for this. So this will also be from Hugging Face. Now, on top of that, to make this work on your local machine, there are different applications here or different libraries. Here in this case, we are using llama.cpp. But then this is sort of like an inference program, right? I mean, if you don't use llama.cpp, you'll probably use something like VLLM or Hugging Face's TGI or text generation interface. Or you also have TensorRT-LLM. Or you could just, raw dog it with, PyTorch transformers, whatever. But this is what it is. On top of it is basically where Ollama is. Again, Ollama is just one of the many things that you can use, and I like Ollama a lot. But similar to Ollama is basically tools like, probably I should make this smaller. Let's see, smaller, yeah. So similar to Ollama is basically LM Studio, and there's also Cobalt. Etc. So there are many of this. So what we are interested in is basically Ollama. And this is what we want to know. And Ollama basically also provides an API server on top. So this is the HTTP API and so on and so forth. So what we want to know is about this piece and how it interacts with llama.cpp and how it works. So just to also give a quick look at this. So I can say Ollama, so let me clear this. Ollama run Dolphin Coder, or let me start Mistral. Mistral 7B instruct. And what I'm going to do is, maybe I should just do this here. Yeah, I'll do this here. So you see Ollama that's running here, and I want to, if I do Ollama, let me also increase this font size so that it's easier for people following on the phones. Ollama run Mistral :7b instruct. So what it will do is it'll actually unload the previous model and then load the new one, and it'll give me this. So it'll say generate a poem on the planets in our solar system. I'll go ahead and generate a poem for this. It's not too bad, right? So, yeah, it does include Pluto. All right. And it also includes Planet X. Oh, does it? No, it doesn't. Anyway, so that's that. So, but if I switch this, so if I, for example, Control T, and then I use Llama 2.7b, or I can do Dolphin Coder again. And notice the, let me put some lines in here. And if I do this, so what happens is it actually would have, let's see. Yeah, so what it does is that it will deallocate the previous model and then it'll load the new model, which I found is like really cool. And I found that it since it automatically manages this, it's okay for the current use case, right, where I'm only running one model. Obviously this doesn't help if I have a beefier machine and then I have I'm running multiple models. Probably it's not going to help, but for like most of our use cases where Ollama is essentially running on the laptop trying to ease our workflows, I think it's like a very good a very good sort of like a compromise to do that. So we're going to figure out how all this works. So let me go ahead and clone this. So go to Ollama. Okay, the GitHub is right up here, and I'm go ahead and clone this. And then see how that's going to work. So I am running old version. I'm pulling this from the main branch, so it may not always be there, but then we'll figure it out. We'll figure out what's up and running. So locally, I'm not going to download it. Ollama, we did a bit of that. We'll look at it. Is there a way to build it? Okay, build it. So I need CMake and Go. I already have CMake. I already have Go. Then I generate the dependencies, and then I just do a build. That should work. Okay, go generate dot slash dot dot dot. I'll also make sure that I kill Ollama here. And let me also kill the screen. So it's going ahead and building this. Ooh, it's actually calling CMake. We'll also figure out why it needs to call CMake. So obviously it's compiling llama.cpp as well, and it is creating these metal files. And so it also makes wait, where did it go? So it makes a Ollama server, and it writes a binary called Ollama server. So I guess this is this independent binary to do this, and then we'll also go build dot, should give us Ollama out. Let's see. It is Ollama. Yeah, Ollama's here. So this is Ollama here. So let's run Ollama serve. Ollama serve got killed. Why? Doesn't it have the X flag on it? That is weird. Maybe I should move my... Let me just move this. Let's see. It just crashes. Okay, that's something that we need to figure out why. That's not good. Maybe I should go to a stable branch of sorts. It main should work all the time, but yeah, let's see why it died. Oh well. So all right, so when we start the app, okay, let's start with the CMD. So this uses Cobra. So let me pull my handle here. So is there a main function here? Okay, there's a main.go here. But I guess this is for the front-end app, I suppose. Oh, this is the app. This is not what I want. So we do want the CMD file. So let's start with start Darwin. And it says start for server. So let's find out who's using start app. Let's look at VRR. So the CMD has it. Check server heartbeat, does that. So okay, so let's find out who's calling these. So this is in run handler, and run handler is I guess this should be the main function. Oh, this is the new CLI. Okay, function. So who's calling new CLI? So new CLI is right here in main.go. Wait, did I miss the main.go here? Okay, this is main.go is right here on the root directory. Got it. I should have seen that first. All right, so it goes to new CLI and then it does an execute context on this. Okay, good. So new CLI has this stuff, and new CLI, if I do a serve, so let's look at serve. Yeah, serve CMD. So serve CMD should basically do a run server. Run server should do this. Let's first find out if it comes here. I'm Let's see if this works. Go build again. Ollama serve. No, I guess it doesn't even come there. Okay, that is interesting. All right, let's see. Println hello world. Let's see if this works. One of these days I'll learn how to type. No, okay, let's see if this works. Wait, what is happening? It is a Marco executable. I'm wondering if there are some other reasons why it's not working. Yeah, there are no other dependencies apart from the security and the Objective-C, this metal core graphics. This seems all fine. I guess metal is required for llama.cpp for it to run. But there's nothing that should cause this. Maybe there's a problem with my Go version. Let's look at go to mod here. Which version? Go 1.22. Version 1.22. Nah, this is like weird, man. Let me see. App cd test go app main.go. All right, so let's see. Let me do a go mod init.com. App. And then let's basically go and do a. So let me go ahead and build this. Go build. All right, this works. So now I'm super confused. So all this works. So there's no problem with my Go toolchain. I guess something has to do with this is in package main. So Ollama, this is the one that should be running. Oh, that is so weird. Okay, so go build local. So That is so weird. So when I run main.go, that works. Okay, let's serve. That is ah. I have no idea what's happening here. So if I do a go run main.go for stral 7b struct. All right, all this works. I mean, this is so weird. I don't know. I have no idea why this is happening. Yeah, I'm just gonna let this run and then we'll kind of like go deeper into this. So one thing is clear. So we have, so let me pull this here. So we have the Ollama server, and the Ollama CLI is basically communicating to it. And there's an API that runs, right? And this is over the HTTP interface, right? So do that. Yeah, I have no clue why the particular binary is not running though. Does the tool shield say anything about that? Okay, the README doesn't say anything. So build. So we can do go run main.go, run mistral. Sorry. And it says llama runner process no longer running. I think I've gotten a very bad. I think the trunk is not in a stable state, I suppose. What I'm going to do is I'm going to figure out if they have cut releases and then look for those. CB132 RC1. So I'm gonna go to that and then go from there. Head git RMO. Just do it. I guess it's git ignored. And now let's do git checkout v 1.31. Let's do 1.31. I'm not sure which version I have. So I'll also move my scale this process. Move that and let's check out tagging v0.1.31. Sorry, v0.1.31. So hopefully this should be better. So let's see. Go generate dot slash dot dot dot. Yeah, we did a git clean hyphen fd, so but it's better to have that now. All right, so this wrote, so it should have written the okay, this writes the libxt server dilib. Wait, was it there the last time? I thought we wrote a binary the last time. Okay, I must have caught it between this. So probably they're migrating over from a dilib to this, but let's say go build dot. Okay, this is this current Ollama. Okay, let me do one thing. MV pen. Oh, let me do this. So I have my home bin directory. I'll move Ollama to my bin directory. I'll move it there and I'll set the path on this. So I'll move my, oh shit, I shouldn't have done this. So now if I start this, Ollama should give me this. So it still dies. I don't get it. So Ollama should be a fairly standalone binary. This all seems fine, actually. So this is because it's integrating with the metal framework. But okay. Let's see. That is so weird. So let's see. I'm wondering if it's trying to load something from a path that is not there, or okay, let's see. Mm, let's see. Go generate. I will also expose. It's interesting. I thought it'll make a incremental build. Okay, now let's look at go build. I am flummoxed. Let's see if you can detrace this. But I can't do detrace without using CSR util, can I? Let's see. This is weird. Because I believe there's some sort of like it's not loading something. I'm not sure what it's not loading. Some binary is not being loaded. Yeah, I don't want to do CSR util on this. Let's see. But anyway, so on to the main thing. While the Ollama binary isn't running, which is very weird. The point is, at least this should work. Because there's literally nothing happening here. So let's see. Okay. So there's some linking that's failing here, actually. So let's look at some of this. Okay, let's. I suspect there is something here that's happening. So let's look at ext server's code base. How does this work? So ext server, let's look at the Go code and then go from there. So okay, not llama.cpp. So din.ext server.go, din.ext server. Okay, so this is loading the header, okay, and then it so it's loading the din.ext server.h, and so let me get rid of these for now. These are all here, but we'll let me also just do this. I'll just do a bear go build, just so that it creates that compile commands server. So this should have generated the compile commands.json. And let me go ahead and also set clangd on this. Compile flags, violation database. I'll call it the current directory, and then so now it should load our. It should be fine now. So let's go to the. Let's do a LSP restart. All right, so it's able to find these symbols now. All right, so this is the one which actually is going to do the Llama server stuff. Okay, let me look at the shenanigans that's happening here. This is actually loading a. Why though? I mean, so they're not dynamically linking it. So this library is loaded. Oh, wait, what? So now if I do a, okay, this is interesting. So if I do a file otool, otool -l Ollama. So this. So this is not depending on that libext server.dilib, although that gets created. So it's resolve, and then this the core foundation. There is lib C++, the accelerate framework, the foundation framework, and then there is metal kit, MPS metal performance shaders, and then core graphics, I guess, which is used by this lib Objective C, and then you also have what's this security framework and user lib system B. I don't know what this is, but I guess this all is there. But what's curious is that it is not loading the other library, and it looks like that library has to be loaded by that's what is loaded by DL open. So someone should call DL open. So who's calling load library? So it should say load library. So on din init, so din init should call libpath. So let's look at who's calling din init. So din ext server go should then call din init. Okay, so here, okay, so libpath is lib.c string of library. So where's getting library from? So okay, who's calling this? VRR. So let me so this is being called here, and so this is range din libs. And where is this Ollama? Okay, it needs to get get din libs of GPU info. So if GPU info is default, otherwise it's if it's only metal, so available din libs. So there's got to be an init method here that's writing this stuff. Who's writing the available din libs then? So who, I'm super confused. So how does it know? So that means, so here when I do, so okay, let me get rid of my Ollama here. Ollama. So if I go, so here, so the Ollama project is here, but then so wondering where is the, so this doesn't have the libext server anywhere either. So this is the GPU helper app. We can reproduce. This is the binary that's there. So is this binary not the one that's on the open source project then? I may be wrong. Let's see. So that could explain why this is not starting. But this available in libs is this Ollama GPU. I guess that's going to give us back here. Okay. But this is all for CUDA, NVML, GPU Darwin. Okay. So this is only going to be built for Darwin. You get the core graphics foundation, and you only get the max VRAM here, and then get GPU info is there. So GPU info is metal. Okay, this is good. So we got all this stuff happening here. A couple of Objective-C files as well. All it does is that it calls that MTL create system default device. Okay, that's all fine. Yeah, what I wonder is I think I should probably delete this build directory. And then run this again, just to make sure I haven't messed this up. So this wrote it in Llama CPP build Darwin ARM64 metal lib libext server.deal by lib. So this is in a different location now. So this is in Llama CPP build Darwin metal ARM64. The compile commands is also here, and this has the lib directory here, and this is where this is. So this seems okay. Now if I were to, so this is the ext server that's there. So when we come to this server and we load this LLM, oh, this loads the din.ext server, and this is the one which has this whole stuff in here. It uses the accelerate metal framework and debug all this stuff. So this is where I'm like really confused, because it expects us to load a library. Let's see if it comes here and then it fails. There's let's see if setting this environment variable works. Code. llama.cpp. So this is liblama.a here, and also the ext server. This is static server, okay. No. Let's see. I seriously doubt if this would load. So let's see if you're able to get here. Doesn't come here either. So this fails even before this. So that means that it fails even before check VRAM. Okay, let's do this. Oh, probably because it's... I have to do a go build. But the new of LLM shouldn't even be created, isn't it? So some init function is failing actually. So maybe here. What happens here? Native init. So let's try getting this here. So I think this is failing here. Let's... repeat it. Okay, no dice. I should probably figure out how logging works and then do this, but yeah. right, so this is not this in it. Yeah. Because this seems to be this doesn't seem bad. Can I let's look at generate. Maybe we can force it to link statically. So okay, this is not AMD 64, this is ARM 64. And then they do a compressed libs. Okay. And there's a cleanup. So let me not compress libs. Let's let's understand what this happens. So now actually Gen Darwin is the one that's going to get called, and the script is generated we run inside. Well, it must be okay, after this gets generate Darwin basically does this, okay. Then the next server.go basically now right? Let's see. It starts that main loop here, but this is all. Yeah, this is not going to load the. So how does the available libs get the directory though? That's what I don't get it. Okay, if it does return default, what does that load though? Who's using this? Is there a config that I should have? These are mostly test. Let's find out who's writing to this availability in libs. So there's gotta be, okay. This is not exactly. This is a native init. So this writes availability in libs. So variant is libs. Oh yeah, this is the one which is gpu.payloadsdir. Payloadsdir is so wait, what? So here, after it makes this, so this actually takes the build libxt this thing, it gzips it. Okay, so this okay, this embeds it within that. Llama CPP build Darwin ARM64 lib dilib. So okay, so the embed fs. Okay, so go build should do the embed. So so it can read from this. Okay, so this should be there. So payload comment, so gpu.payloadsdir basically gets from so so who's using So here then we do the extract, and then this gets the lib embed. Okay. So let's try writing this. So is there a way to spec embedded folder? I was wondering if I can extract the embedded, but anyway, let's see. Can I so the payload comments native init. Okay, let's see. Let's see if this works here. It doesn't even come here. It's an LLM, but oh, LLM has okay pay.com. Okay, got it. So this gets embedded. So this library gets embedded into the embed.fs, and then it kind of loads it from there. So the native init basically extracts it, and that's why it's not there. So it's essentially a part of the binary. So it calls a native init yet again here. What's my version of Ollama? So 1.30, just for the sake of sanity, I'm going to One dot. Okay, it does a submodule in it. And it will sit. Let's see if this is any better. I just deleted the entire directory and created it again. So maybe this time might turn lucky. Let's see. Okay, go. Okay, no dice. But we're able to follow this thread on where it loads it. So I'm just not sure. So let's just see if this, because I'm still doing the initialization here. So if my theory is right, it should still not work with this. Yeah, it kills. So definitely. Okay, let's. So CMD basically loads everything. So one of them is essentially the problem here. I would bet it's this. Let's see. So what is this supposed to return? I'll just say return nil here. So if I don't start the server, it should. Okay, let's see. That is weird. So it is not the server that's causing the problem. That's interesting. So what else is causing the problem? Container ID console. Okay, that's probably because table writers, slices. All right, a whole bunch of files are going to. So let's look at these. All of these are returning an error. So what I'm going to do is, I know this is a bit extensive. This requires create prompt. Let's see. Go ahead. Oh, that's my daughter here. You're, I'm streaming to the whole world. All right. So I don't even know. Do I need run options here? But yeah, we'll get that. So no. So maybe we can. Wow, this is extensive. I'm gonna do something else. I'm just gonna um, what I'm going to do instead is now I'm gonna so that way we'll know exactly what is causing the problem. So ah, okay, this starts the app. It's it's not used anywhere else. And this is return an error. All right, so this loads, obviously, has to. Uh, so now let's start uncommenting each of them and figure out where it fails. Okay, this is good too. This is good too. All right, so this is basically where it fails, obviously. So let's look at server. Server is obviously where LLM is being called, so server itself may not be a problem. This is unused parameter, that should be fine. What if I GCC the whole thing? We said this should still fail. Just need to figure out which parts are not failing. So let's do a. So does the is API okay? I think API should be fine. Oh, API itself isn't fine. That is interesting. Okay, is this fine? Okay, this is not fine. Okay, we are not fine here. Wait, what is happening here then? In CMD, this is fine actually. The moment you get the server package, it dies. So we are kind of loading the API or the somewhere else. This could also be an option. Yeah, it's like comment driven development. This works. And now we just need to figure out one thing that loads the Ollama call, I mean the LLM call, and then debug from there. So okay, so GPU itself fails. So if I have GPU that fails, okay, let's look at GPU. That I need it here. So, okay. This is just wait, does GPU depend on LLM? So these two are tests. Okay, now there's so this is GPU info darwin.h. So this is what is going to get built for Darwin. So this is going to be built only for Linux or Windows, and this is going to be built for everything. So let's try to understand this. So here, okay, it does this import, blah blah blah. Okay, oh, sorry, no, GPU Darwin. Okay. So this is the one which has this. So ideally speaking, there shouldn't be any init here or any type here. So basically including GPU info fails. So how do I check if this alone works? So I can go to server.go, or no, server routes go. If I comment out this and run this works. So I can go to main.go and I can get you, Ollama. So this should fail. Should it not? Yeah, this fails. Why though is the question now. All right, so now this, okay, check out. Should be fine. So we have a bunch of them. Let's go back to the head and let's go to main.go, and here in this case, let's comment this out. Let's just get the GPU part of it. And GPU dot. I think my LSP has gone for a toss. So let me just get firmed here for now, and right, this fails. So let me just get restart. GPU dot should work, isn't it? So get GPU info should work. Right. Let me just start them again. So the LSP is there. So let's see if this works. Okay, this dies right away. So somewhere here is basically where the problem is. So now let's get. So we have the metal framework and the GPU info darwin.h, which has this, and this is go build Darwin as well. Okay, okay, so if the test passes, this test is useless. So think this. Yeah, so it's not even the LLM that's a problem. It's the GPU info that's causing an issue. And I don't even know why though, because pretty much this is the only thing that I see would get included. So this has framework core graphics, and metal. Well, it has the GPU info darwin.h. And just importing this library fails. That means there is no init here or any of that stuff either. So get recommended max VRAM is basically what is here. So when you do this GPU info, okay, so this gets max VRAM, check max VRAM. GPU info basically, so this mem info is mem get CPU mem. So it's just going to give you 0. I don't even know why this is a problem actually. Who's using check VRAM? LLM is doing check VRAM. And routes is also doing check VRAM, okay. This is only for yeah, that is so weird. So does it not work on anything else? Oh no, it would, but it would. I should check the GitHub repo for. I don't even know if this is an issue with my machine or... The Ollama itself is not a problem. It's just that my build of Ollama is a problem. I'm not sure if it is to do something with my toolchain. It's not compatible with this thing. I have GCC as well. That could possibly be the problem. Let's see. Right, I think I'm going to stop the stream today and then I'll pick this up in the next stream. Yeah.